In this recording, we're going to learn how to rationalize denominators of fractions. Now, basically what that means is, if we have a radical in the denominator, while not technically wrong, we don't consider it to be simplified form. So we want to express this fraction with a rational denominator as opposed to an irrational denominator, one that has a radical in it. Okay? Give you a second to jot down the heading and these three examples, and we're going to work through these. Okay, so if you have radical 3 over radical 11, we don't care so much about the radical 3 in the numerator. That's fine, but the radical 11 in the denominator is not considered simplified. So we're going to multiply the numerator and denominator by a form of 1 here. So we're going to multiply by square root of 11 over square root of 11. And the reason for that is square root of 11 times itself makes square root of 121. So numerator, we get square root of 33. Denominator, we get square root of 121. What we've done is create a perfect square in the denominator. It's not that the radical has gone away yet, but we've created something that we can evaluate to be a rational number. Now the denominator is just 11, and the numerator comes out however it comes out. We don't really care so much about the numerator. It comes out radical 33 over 11. That's fine. Our next example has a cube root of 5 in the denominator. It wouldn't work to multiply by the cube root of 5 here. In other words, multiply by itself, because 5 times 5 is 25, and 25 is not a perfect cube. So instead I have to ask myself, what can I multiply 5 by to give me one of my perfect cubes? I'm going to list out some perfect cubes. We got 1, 8, next one would be 27, 64, 125, etc. I think 5 goes into 125. That's the first one I can make. So I'm going to leave a little space here and make a fraction. I want to create the cube root of 125. So this is the question I'll ask myself, and I'll write it out. What can I multiply 5 by to get a perfect cube? All right, so let's write that. What can I multiply 5 by to get a perfect cube? All right, and that's what we're going to do. We're going to multiply by the cube root of 25, because 5 times 25 gets us the 125 that we know we can cube root. All right, and in the numerator we'll do the same thing, cube root of 25. So the numerator, we just get whatever we get, right? We get 8 times the cube root of 25. That's not a perfect cube, so I'll just leave it. 8 cube root of 25. But in the denominator, I get the cube root of 25, which I happen to know. Remember, it's on our list of perfect cubes. It's a 5. That's considered simplified because we've rationalized the denominator. We've made it into a rational number. Okay, for number 3, you have a square root of 20. So we can ask ourselves, we can actually do this 2 ways. We can either ask ourselves what we could multiply 20 by to get a perfect square, or we can just multiply by the square root of 20 and we will get some perfect square, not necessarily the lowest perfect square. Okay? So I'm going to multiply this by square root of 20 over square root of 20. And in the numerator we'll get 10 square root 20. Denominator we're going to get 3 times the square root of 400. But we know 400 is a perfect square. It's 20 squared. So numerator, we get what we get, square root of 20. Well, as we're rewriting this, we may as well simplify it, right? The square root of 20, we know it can be broken down. We know it's got a perfect square that goes into it, right? We're familiar with that one. We've done that one before. So we're going to take out the perfect square that goes into 20. Instead of writing square root of 20, we're going to write square root of 4, square root of 5. Okay? So up in the numerator, I know this is square root of 4 is a 2, right? So 2 times 10 is 20. 20 square root of 5. In the denominator, I've got 3 times 20, because square root of 400 is 20. And now these 20s, being factors, can divide out. So I'm simply left with square root of 5 over 3. There is a shorter way I could have done that. If you're saying, well, couldn't I have multiplied the square root of 20 just by square root of 5 to start out with, and I would have gotten square root of 100 on the bottom? There's certainly an alternate way we could have done this, and possibly saved ourselves a little step.